Okay. There was a question on number, was it 14? Was that the one? I want to know if it is y to the 8th. It is y to the 8th. Holy crow, I did it too quickly. Yeah, 14 should be y to the 8th. I'm sorry. I went through too quickly, so that's incorrect. Any other questions that we might have come across? We good to go? Sneeze? Are you all right?
What?
You're all right?
Yeah.
Okay. Any others that you need me to run through, talk about? Yeah.
Is that, wait, 6?
Which one?
28. Is that negative 6a?
28. Negative 6a to the, oh, it should be to the 9th. So negative 6a to the 9th. That should be to the 9th power. Boy, I tell you, I'm just off base today. Okay, so that one should be to the 9th. And that one should be to the 8th. Man. Any others that I goofed up on? One thing to make note of is this one right here. When you have something, if you have something raised to the 0 power, if you have a letter or a number other than 0 and it's raised to the 0, the answer is 1. It comes out to 1. So that's just. Are we good there? Can I move off that screen? Yeah. Sir?
A question about 29.
29. Yes?
So, like, when you're adding the exponents on top.
So that to that, that's 6, and that to that is 6, right?
Right.
And then that's a 1 in front of there. So then they're like terms. Because 1x to the 6, 2x to the 6, you can add them together. It becomes 3x to the 6th. So are you okay to this point?
Yeah.
Okay. And then meaning because they're like terms, it's the same base, same exponent. When you're adding them together, you're just counting them now. So the exponent doesn't increase.
Oh, okay. I was wondering why it wasn't 12.
Because they're next to each other and you're adding, so you're just counting how many x to the 6's you have.
Okay.
So you have 3 of them. If they're multiplied, then you would add the exponents. Yeah.
What about for number 27? Wouldn't that mean you would have to put like a 1 before the x and the 3?
Let's see. So this right here would have given me x to the 5th, right? So 1x to the 5th. So I'm working this one down here. Plus 2x to the 5th, like that. And then, oi, my goodness. Oh my goodness, are you kidding me? I gotta quit sniffing glue. Don't you think he's serious? Jeez, 3 errors? Oh my, 4 errors. Oh, paint eater, you got that right. Did I make any other errors that I'm not seeing? Jeez. I'm sorry. Yeah.
What if the exponent's on like terms?
What's that?
What if the exponent's on like terms?
Which one are you looking at? Oh, if the exponents are not like terms? So like if you had x to the 5th plus x to the 4th, you can't combine them because they're different dimensions. But if they're x to the 5th and x to the 5th, that would give you 2x to the 5th if you were adding them. So like this one. So you had x to the 8th, x to the 4th. They're not like terms. So you just have to, if you're adding them together, you're just going up. Holy cow. Can I get off this screen before I start making any more errors or discover any more mistakes? Sheesh. Whew. All right. Ooh, what's this? I don't want that. Let's go. Let's see how this one works. All right. Product of powers and power. Okay. So this is a little bit of a review of what we were talking about. Product of powers. So if we were to talk about just the product of powers, this would be like x to the 10th times x to the 10th. So being that we're multiplying them together, this would allow us to get x to the 20th. Now, where some of you are going to make an error on this, as well as me, obviously, if I had x to the 10th plus x to the 10th, now I'm adding them together. So how many x to the 10ths are we talking about? There's 2 of them. So this answer would be 2x to the 10th if we were adding. But if you're multiplying here, that means we're going to add the exponents. Okay? So if you're adding and you have completely like terms, the letter's the same, the exponent's the same, then you're just going to count how many you have. If you have the same bases and you're multiplying it, then you add the exponents. And then power of a power, the power of a power, this would be like x to the 10th raised to the 10th. Now we're going to multiply the exponents, so that gives me x to the 100 power. So power to power, so exponent raised to an exponent, you multiply the exponents. If I was multiplying 2 bases together and each of them has an exponent and they happen to be the same bases, then we add the exponents together. And if I was just adding something with an exponent to something else that has an exponent, and they happen to be the same amount of exponent, you know, to the 10th, to the 5th, or whatever, they match up, then you just count how many you have. Is that okay so far? Okay. We're on a different screen on this one. Let's see, where do I want to? Where's my clearing of ink? I see an eraser. I don't see a clear ink up there. Do you guys? No. We'll go to the larger eraser. Oh, you know what though? I betcha. Oh, yeah. And take a look. The ink's still there. I like it. Okay. Review of powers. So 5 is the base. 3 is the exponent. It means 5 times itself 3 times. So 5 to the 3rd power, some exponent to the 3rd power, or some base to the 3rd power means you're multiplying itself multiple times. So this would become 5 times 5 times 5, which is 125. So let's see if we have some things. So product of powers property. So 5 to the 3rd times 5 to the 4th. The 5s are the same base. We're multiplying them together. So I'm going to add the exponents. So this basically means 5 to the 3rd is 1, 2, 3. There's 5, 5, 5. And then 5 to the 4th, 1, 2, 3, 4. And if you were to count, 1, 2, 3, 4, 5, 6, 7. So I have 5 to the 7th power that I'm multiplying. And again, when we're dealing with exponents, there are certain values that are small enough that we could get away with giving an actual answer. Other times, like 5 to the 7th power is a pretty big number. Your calculator probably could do it, but I'd say leave it as is for now. So, let's go around the room, see how we do. Ray, 3 to the 2nd, 3 to the 6th. Where do you want to go with this one? 3 to the 8th? Angela, you agree?
Yep.
Because, let's see, we had like bases, we were multiplying them together. So, Christian, we added the exponents. Does that make sense? All right. Mr. Garvey, what do you think for number 2?
2x6.
Pretty close. I like the x to the 6, but why is it not a 2?
Why is it not a 2?
Yeah, why would I not have a 2 out front? Though you're exactly right, having the same bases.
Because it's not the same exponent.
It's not the same exponent, and we're not adding them together as well. So if you want to think about this, let's use this property up here. X to the 2nd is x times x. Is that okay so far? And then x to the 4th is 1, 2, 3, and 4. And then if I count these, I got 1, 2, 3, 4, 5, 6. So this is the same thing as just x to the 6th power. All right. Does that make sense? Okay. George, what are your thoughts for number 3?
We multiply x and 2x to the 2nd power.
Okay, so it's multiplication exactly right. What was that used when we're going over parentheses? What was that rule called? Starts with a D. Nope, distributive. So I'm going to distribute here to here. So what do you think? X times 2x to the 3rd. Does the 2 come along for the ride? Okay, and x to the, so I get 2x, and I have x to the first and x to the second being multiplied, so what do I do with the exponent? Add it together, good. And then Megan, if I want x to the first times x to the fifth, what do you think I'd got to get there? X to the sixth. And the plus sign is going to come along for the right. And I can't go any further on this problem. That's just as simplified as we get. Okay, taking a breather. Are we okay? So the distributive property is going to work with these. If we have like bases and we're multiplying them together, we're going to add the exponents together. And then when you have some number to an exponent, it just means that's how many times you're multiplying whatever that number is. If it's a letter, that number is a variable then. May I move off this screen, or are we still tied on this one? All right. The power of a power property, okay? So they're giving us the example 5 to the third squared, which means I have 5 to the third and 5 to the third. And if it's like this, that would mean I could add them. So the third, so 5 to the sixth. Okay? So that means that in this case, this is being multiplied here and here. Or if you wrote it out, then that means you're just adding there and there. So if I have a, which is some variable, raised to the m power, as the quantity is raised to another power, the powers are multiplying together. Okay? So gauge. Number 4, what do you think we're going to go on that one? 2 to the second to the fourth. What do you think it's going to simplify to? 2 by 4. And I'm going to get 2 to the 8th power. Okay? And some people might say, hey, well, what does that answer? You know, can I leave it like that? I like that answer. It's fine. 2 to the 8th is 2, 4, 8, 16, 32, 64, 128, 256. So this is like 256. So it's not an enormous number. I would probably totally take that for an answer without questioning it. But if you felt that you needed to, you could easily do that. Okay, Casey, same exact property we're using on number 5. What do you think? Where should we go? Ooh, I'm coming. It's coming. Hang on. We'll get it there. Now I got to move it up. Whoop, whoop, other way. You see that? What do you think? X to the 6th. Excellent. Good job. All right, escape. So that's going to give me x to the 6th power. Does everyone feel okay about that page? This exponent stuff seems okay. Doesn't seem too difficult. We'll go to slide number 5. Okay. Mr. Kruger, try in that first one, number 1. X to the 2nd times x to the 3rd times x to the 4th. What do you think? What do you think we should?
9.
X to the 9th, because 2 plus 3 plus 4 is 9, so x to the 9th power. Awesome. All right. Tristan, giving you a tougher one. I'm sorry. So the first -2, what exponent is that raised to, would you feel? What do you think this is raised to right here? If it's nothing's there, what do you think it would have to be raised to? Well, that is to the 4 right there. But what do you think this right here should be raised to? If it was 0, if that was 0, that would make this whole thing 1. And I like your thinking, but a lot of times, like if I just have the letter X sitting all alone, what's in front of that letter X? A 1. And so that's kind of the same thing with this. So this is actually to the 1st power right there. So using our rules, do you feel the answer is going to be negative? Okay, that might be a good choice. So let's take a look. Okay, how many of this do I have right now? I have 1. Okay, we're good. We're solid right there, right? Okay, how many of these do I have? Cool. 1, 2, 3, 4. Oh, sweet. Okay. Huh? Think it's going to be positive? Hang on. Ready? Negative times negative is? Times a negative? Nope. Negative times a negative? Times a negative? Ooh, it's going to be a negative answer. How many negative 2's am I dealing with? 5 of them. So what I would do here, just to keep things safe, is this started in parentheses. I would keep it grouped in parentheses. So you could have that for an answer. Negative 2 to the 5th power, negative, 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 negative is going to be a negative answer. And 2, 4, 8, 16, 32. So this answer would be negative 32 if you wanted to write it out. But that's a little trickier one. I wouldn't see that one coming. All right. Mr. Summers. Number 3. Okay. I have negative 3 in parentheses. That happens to be squared. Still with me on that one? And then I have square brackets. And square brackets mean the same thing as parentheses. It's just a different grouping symbol. And that outside squared. So what do you think I should do with the exponents?
You combine them together.
Combine them together. How are you going to combine them? I'm sorry? Multiplication. So I'm going to keep this in parentheses. So I have negative 3 to the 4th power. Okay, how many negative 3's am I multiplying all in a row? 4. So negative times negative is positive, times another negative, times another negative. It's going to be a positive answer. So this is going to be a positive answer because if I multiply a negative by it to itself an even amount of times, it's going to be a positive answer. Let's see. I bet we could kind of maybe work this out. 3 times 3 is?
9.
So that took care of 2 of them. And then 3 times 3 is? 9. That took care of the other 2. And 9 times 9 is?
81.
Giddy up. So this would be a positive 81, or you could just list it as 81 for an answer. Yeah.
So why wouldn't you put a 1 over the 3?
Oh, that's a great question. The reason that's not going to happen is it's not a negative exponent, it's a negative base. And the negative base just means it's a negative answer, the negative exponent. And we're going to get to that a little bit more today, where if it's a negative exponent, it means it's kind of unhappy where it's at, so it's going to do a little switcheroo. Okay? All right, number 4, I'm just going to walk through it. So this one got a little trick to it. What is 3 times negative 4? Negative 12. Does everyone feel okay with where this negative 12 is coming from? And then I have x to the second. Stephen, help me out on this one. X to the second, x to the third. Being multiplied together, what do I do with the exponents? Add them together so I get? Yeah, x to the 5th. Okay, so let's take a look here. The negative means I was just taking a positive number and a negative answer, or a negative number, multiplying together. That's where I got negative. Then, with the like bases, the x's, I added the exponents together because they were being multiplied. Whew. I wonder if there's any more slides on this page. Ooh, there is. Page number 6. Can I go there? Oh boy, oh boy. Bo! You ready for this one? All right. 2xyz. That whole quantity is raised to the 3rd power. So how many 2xyz's am I multiplying together? 3. Exactly right. So I have 2xyz, 2xyz, 2xyz. Does that make sense so far? Is that easy to see? All right, Bo, ready? 2 times 2. Times 2. Yeah, so that times that times that can give me 8. X times x times x. Yeah. X to the 3rd. Y times y times y. Y to the 3rd. Z times z times z. There you go. Good job. Pretty easy. All right, Mr. Nix. I have a negative on this number 6. Agreed?
Yes.
Okay, but that negative is in a unique spot compared to where the negative has been. Where is it located right now?
Outside of the parentheses.
Okay, it's outside of the parentheses. So in your opinion, would you feel that that negative is being influenced by an exponent? Is it grouped together so the exponent is there or not?
No.
I think you're totally right. I think that negative is going to come along for the ride until we interact it with something else. So I like this so far. Okay? So I think that this negative needs to just come along for the ride. Is that all right? How many 2x to the fourths do I have? 4. Wait, how many 2x to the fourths do I have?
1.
2. We'll eventually get there, right? All right. But again, that 2 is influencing this. It's not influencing that. You with me? So basically, this is this. See where that came from? I'm not done with the problem yet, but is that okay? So this negative comes along for the ride. Okay? It's not being influenced by this outside exponent. This outside exponent just basically means, hey, I have this twice. All right? All right? Negative 2 times 2.
Wait, what? Sorry.
Negative 2 times 2.
4.
Real close.
Negative 4.
Negative 4. Good. So I'm going to get negative 4. Okay. X to the fourth, x to the fourth. Being multiplied. X to the fourth times x to the fourth.
X to the 8.
Yeah! We got it. I think we're doing all right. Oh. Crystal. Can I pick on you? Okay, I'm calling on you anyhow. Ready? We can get through it. All right, problem number 7. Still with us? Okay. I have 2x squared, but it's in parentheses, so it's being held together, and that's raised to the second power. So 2x squared squared. How many 2x squareds am I multiplying together? Good, 2. So I have 2x squared times 2x squared. That's the same thing as that. Does that seem okay so far? And then 3x to the fourth, we're just going to carry along. You still with me? Let's see if we can figure this one out. All right, Crystal, ready? 2 times 2. That gives me a 4. Okay, so I have a 4. X squared, x squared. X squared times x squared. Almost. Oh, say it one more time. I'm sorry. X to the fourth, absolutely. And then I have this one right here, so plus 3x to the fourth. Now, in your opinion, so hang on, let's clarify this. So like terms are the same letter and same exponent. Do we have like terms up there? Yeah, so what is 4x to the fourth plus 3x to the fourth?
7x to the 8.
You're so close. I totally agree with the 7x. Okay? But I'm only adding them together, so I'm not going to increase my exponent size. I'm only counting. So if I don't change the exponent, I'm only counting. What does the exponent have to say? You do. I'm only counting. How many x to the fourths do I have here? How many do I have here? How many do I have total? 7x to the fourth. I have 7x to the fourths. So we're not increasing it at all. Reese, coming to you, buddy. Yeah, Angela, what do you got?
How come on the one number 6, one before?
Uh-huh.
How come it even goes in x to the 4th?
Oh, that's a great question. This is why. Okay. I was multiplying them. So when I'm multiplying like bases, I have to add the exponent. Here, I'm adding them, so I'm just counting them. So different math operation. That's a great question. We good to move on? Reese, you ready? I saw you with your eyes sagging a little bit, so I figured I'd call on you. All right. How many of these am I multiplying together?
2 of them. Wait, are you doing 2 of them because of?
How many of those? How many
Oh, you're doing. Is it 3?
Yeah. So I have 3xy squared, 3xy squared, 3xy squared, and then I'm going times that, times x squared y. Woo! Okay. All right, hang on. Let me change colors. Okay. We can do this. 3 times 3, Reese.
6. Yeah, I'm sorry,
9. So 9. 9 times. So 3 times 3 is 9 times another 3. 9 times 3.
Isn't that like 27?
That is 27. Good. Okay. Whew. All right. We're almost done. Almost done. Okay. So I'm multiplying bases, and the base I'm going to go to right now is x. So I have x to the first, x to the first, x to the first, x to the second. So if I'm multiplying like bases, I'm adding the exponents. So I'm going to go 1 plus 1 plus 1 plus 2. 1 plus 1 is?
2.
Plus 1?
3.
Plus 2 more.
5.
X to the fifth. And again, because I'm multiplying them. So now I'm going to multiply the y's. So I have y to the second, y to the second, y to the second, y to the first. 2 plus 2 is?
4.
Plus 2?
6.
Plus the 1.
7.
There you go, y to the 7. Done. Oh, I'm getting good at these. With your guys' help, we're all day long in it. All right. Ready? All right, quick question. 50-50. And I suck at 50-50, so you're going to be good at it. Is it going to be positive or negative? God, you're as bad as 50-50 shots as I am. Okay, I like your thinking, but let's take a look. Okay, this is sitting outside of the grouping, the parentheses. Do you agree? And I only have one of them. So it's got to come along for the right. Is that okay? So change your answer. Go with negative. Okay. So negative's coming along for the right. Now we're done right now with that. How many of these do I have? How many of those are being multiplied together? Just right here? What is that? 2? Right? So I have r squared s third t5, r squared s3 t5. That's just from right there. Is that okay? Oh boy. Oh, and then I have, oh man, I gotta squeeze it down here. Okay, if I don't get back up, make sure you guys point left. I have 3 of these, right? R3ST5. Uh-oh. R3ST5. Oh my gosh. Okay. I gotta get rid of some stuff. I got too much stuff up here. Sorry. I know some of you put some good hard effort into this one, but I'm gonna erase that. I don't want to see this right now. Okay, I have 1, 2, 1, 2. Oh my goodness. All right. Everything's being multiplied together. Let's stick with the r's only. I think we can count this. So if I have like bases, in this case we're going to deal with r's, so those like bases being multiplied, we're going to add the exponent. Still with me? And this negative here is going to stick around for the right. So I'm going to keep the negative. Okay? That negative is right there. We're good? We're not going to worry about it. It's coming along for the right. Okay. R squared, R squared, R third, R third, R third. We're just adding them up. So 3 plus 3 is? Plus another 3, plus another 2, plus another 2. Yeah, buddy. R13. All right, let's change colors. S's. S to the third, S to the third, S to the first, S to the first. Those are all to the first, right? Okay, we're counting them up. S to the third is X to the sixth, and then 1, 2, add 3 more. What? 9, R9, or S9. S9. Make that S9. Okay. Okay. T's. T5, 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 T5. 5, 5, 25. Yes, T25. Remember the negative. Woo! Nice. You got picked on for the hardest one. Sorry. Kind of sort of get this. I think. Wouldn't be bad if I taught the whole lesson wrong. Like, okay, forget everything you just learned. I think I taught it right this time. You want to know why I taught it right? Because I went around the room. And I think I asked almost everybody. Those who haven't been asked yet, don't worry. We're coming. All right. Do we have time to do just a smidge more? No? Make you a deal? Let me do a smidge more. You walk out of here without homework.
Yes.
Deal?
Deal.
Y'all with me?
Yeah.
Yep.
Giddy up?
Yeah.
Okay. But here's the deal. But here's the deal. That means that tomorrow during class we'll have to do what the assignment was supposed to be. Is anyone going to cry themselves to sleep if that happens?
No.
You already did it? You're better off than us, the rest of us. 14 is pretty short, but we'll do it as a class. All right, you ready? Can I get rid of this? Does anyone need a stretch break? Poke your neighbor in the eye?
No.
Stick your finger in your mouth and then stick it in your neighbor's ear?
No.
That's a wet willy. I don't know what Willie ever did wrong. Whoa! Okay. Woo! All right, you guys ready? You guys ready? Can we make it? Hang on. First, before I say that, let's see. How many slides do we have? We got, really? Holy cow. Okay. Okay, well, we're only going to get some of this done. But I think we're okay. You guys ready? You guys set? Okay. Working with linear expressions, number 14. Exponent rules. So a negative exponent. Angela, you were asked about that negative exponent before, weren't you? Okay. And then zero exponent and quotient of powers. So I can simplify the expressions that have negative and zero exponents. Okay, I think that's something we can do. Okay. So a negative exponent means that I am raising something, and the exponent I'm being raised to is a negative number. Okay, zero exponent means I have a base of some number or some letter that's raised to the zero power, and the quotient of powers means division. Now you know what? Division is like a bad word in math. That was like the first bad word you ever learned. The next one was fraction. The nice thing is division of quotient of powers means we're going to talk about the game tug of war. Or tug of war. I don't know what the proper... Huh? Sweet. That's all exponents are going to do from here on out when they're one on top, one on bottom. Okay. I think we can get this. All right, you ready? And I might not be able to teach all of it because I want to make sure this is sunk in nicely. Okay, ready? All right. Solve the... Oh, what... Okay. All right. That looks like stuff we've done before. I think. 2x minus 8 equals 5x minus 4. Help me out. I'm just solving for x. Oh, man, I went backwards. Yeah, go ahead. Subtract 2x from both sides. Love it. Minus 2x minus 2x. That cancels that. Negative 8 equals 3x minus 4. Keep it going. Add 4. Love it. So that cancels that. That's negative 4 equals 3x. Last thing. Divide everything by 3. Is it okay to leave it as an improper fraction? Heck yeah. Good job. Angelo, your favorites. The F word, fraction. How am I going to clear that fraction? What should I multiply? What should I multiply both sides by? What number does 4 and 3 have in common with each other? 12. I like it. So I'm going to multiply this by 12 and this by 12. So 4 goes into 12 3 times, so 3 times x is? Okay. Okay, equals 3 goes into 12 4 times. I'm going to have to distribute that. So 4 times x and 4 times 1. So what's 4 times x? 4x. 4 times 1? Sweet. What do you think we should do? Subtract 3x? I'll go that way. I like that. Now, here's where we're going to kind of run into a silly, but I think we can work through it. You're right. You're absolutely right. What should we do now? To get x all by itself. Say it. You know it. Yes, you do. I want x all by itself. I'm adding 4 to it right now. What's the opposite of adding? Subtract what? Yeah, buddy. Subtract 4 from both sides. So negative 4 is equal to x. Some people prefer it to look like this. Sweet. I like it. Oh boy. You know what number 3 is? It's like the number 1 spot that kids goof up. All right, who have I not picked on? Kids said no. Picked on me again. You ready? God bless you. What do you think? Yeah, you got it right. All right, so some of you are going, oh, I'm going to do it one way. This is the way we're going to go right now. We're going to distribute the negative 2 to both. So I get 5, negative 2x plus 8 equals 5. Now, some of you that are sitting there looking puzzled going, I was going to do it a different way. Your order of operations would be out if you went 5 minus 2. Okay, so you make sure you distribute the negative 2 over the parentheses. So negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. All right. Combining like terms. 8 and 5, that's 13 minus 2x equals 5. What's next? Yeah, buddy. Subtracting 13. Last step. Divide by negative 2. And you know what? I think I'm okay. I don't think I have to. I'm going to do that, and the next one tomorrow. But I think we're also going to do number 14 tomorrow during class. So Monday night, no homework tonight, unless you need to make something up. That sounds kind of good. You with me? Everyone cool? Was it all right how I bounced around the room? I saw some of you kind of sitting up a little bit going, uh-oh, I'm being next. All right. So